In this tutorial, I will explain the concept of modulus and argument of a complex number in a way that is easy to understand. If you are new to this channel, I recommend subscribing and turning on post notification so you'll be notified whenever we upload new videos. Now let's get started with today's topic. Suppose we have a complex number a plus bi. The modulus of this complex number is equal to the magnitude of k, which is equal to root of the real term, which is a squared plus b squared, the imaginary term squared. In this case, you don't add the I to the square of b. No, you just use the real number part of the imaginary part. The real number part of the imaginary part. So the real number part is the b. Let's try our hands on an example. For example, if k is equal to 2 plus 4i, then its modulus, magnitude of k, is equal to root of 2 squared plus 4 squared, which is going to give us root of 4 plus 16, which gives us root of 20. And root of 20 is basically 2 whole number root of 5, or 2 multiplying root of 5. So this is an example on modulus. You can pause this video and try your hands on this. A is equal to 6 plus 6i. I will put the answer at the end of this video. Also, we can be asked to find the argument of a complex number. The argument of a complex number. So suppose we have a complex number a plus bi in this situation. Then the argument of a, which is the argument of k, is equal to the tan inverse of the real number component of the imaginary part. If I say real number component of the imaginary part, it's b. So b divided by the real part, which is a. I'm going to show you a simple way of solving a question with this type of formula, so that you don't get confused with the use of maybe a negative sign or a positive sign. So let's take two examples on finding the argument. So say a is equal to negative 2. Let's make this j. So say j is equal to negative 2 plus 4i. Then we already know that the a component is what? Negative 2. But when we are putting it in the formula, we are just going to write the 2. We'll come back to that. Then for the imaginary part, which is b, it's equal to 4. Now we will find tan inverse of b over a, and that is going to give us the argument of k to be equal to 63.43 degrees. Now this is not our final answer. You see, initially I asked you to drop the negative sign and use just the positive values to calculate for the tan inverse, right? So you would have to come and draw something we call the Aran diagram. So for the Aran diagram, the real part of the complex number will take the x-axis and the imaginary part of the complex number will take the y-axis, right? We know that for this part of a Cartesian plane, this part is positive and this part is negative. For the imaginary part, the upper part is positive, is considered positive, and the lower part is considered negative. And so if you have -2 here, -2 for the real part, it's going to be somewhere here, right? It's going to be somewhere here. Then for the imaginary part, we have +4, which is going to be somewhere here. So therefore, our graph is going to be in this axis, right? With our 63.43 being here. So this portion is 63.43 degrees, right? So if you want to know the argument of k, we have to measure the angle from the positive x-axis. So we measure from here to here, and that will give us the argument of k. So if you want to know the angle from the positive x-axis to this point, then we have to subtract this angle, that is the 63.43 from 180. So we get the argument of k to be equal to 180 minus 63.43. So therefore, we get the argument of k to be equal to 116.57. Now let's take another example. Suppose we have a complex number p to be equal to 3 minus 2i. Then, and we are asked to find the argument. We all know how to find the modulus now. The modulus is going to be the square root of 3 squared plus 2 squared, right? So the modulus will be p, which is equal to root of 3 squared plus 2 squared. Then we get our final answer to be equal to root of 13 for the modulus. Now let's say we are asked to find the argument of p. The argument of p. We would have to find the angle first, which is tan inverse of, we should not mind the sign that is given first when we are finding the angle. So we will say tan inverse of 2 divided by 3, and that is going to give us 33.69 degrees. Now this is not the argument of P. Why? Because we did not consider the sign of the complex number. So we would have to draw our Aran diagram, which is the Cartesian plane that you already know, putting the real term on the x-axis and the imaginary term on the y-axis. So for this, we know that the imaginary term is negative, so it will be at this place, because here is negative, here is positive, here is positive, here is negative. So it will be at this place. And so the real term 2 is positive 3, and that one too will be at this place. So this portion will be measured from here. So this angle is going to be 33.69. And I've already said that the argument is measured from the positive x-axis going down, and so we measure from here. So we move from here to this point, and so we know that from here to here is 90, from here to here is another 90, and so this angle is going to be 180 plus another 90. And for us to get this portion, we are supposed to subtract 90 from the 33.69. But to be safe, we already know that the total angle of a circle is 360. So we can subtract 33.69 from 360 in order to get the angle from the positive x-axis to where this line has been drawn. So we are going to get the argument of P to be equal to 360 minus 33.69, and this is going to give us 320. This is going to give us 326.31 degrees. Thank you for watching this video to the end. Do well to like, subscribe and comment. And in case you need help in any of the subjects that you are going to do in engineering, I will put my handle in the description box so you can contact me. Thank you very much.